3.3, proportions and cross products. So a proportion is an equation in which we equate two ratios. And it looks like one fraction equals a second fraction. Generally, we know 3 pieces of information out of that, and we want to find the 4th. So an example of this would be this equation right here. Phil bought 50 grams of Fitness World trail mix and saw that it had 150 calories. Jen bought 150 grams of Pikes Peak trail mix and saw that it had 450 calories. Do both brands of trail mix have the same ratio of calories? So, in this case, we have 4 pieces of information, which means our proportion is going to be filled. We're just not sure if it's equal. So, I'm going to start by setting up a proportion where I'm looking at grams to calories. So, in the first trail mix, which is the Fitness World trail mix, I have 50 grams of calories, or 50 grams, 150 calories. So, sorry, I don't want the equal sign there. 50 to 150. The second type of trail mix is Pikes Peak trail mix. I have 150 grams and 450 calories. And when I'm not sure yet, before I do my calculations, I put a little kind of question mark in the middle here because I'm not sure if that's going to be an equal sign yet. If it is, then this creates a proportion. If these are not equal, then I don't have a proportion. So, I'm going to use equivalent fractions here because I can see that these numbers easily go into each other. 50 times 3 gives me 150. 150 times 3 gives me 450. So these are equal ratios, which means that these form a proportion where 50 to 150 is equal to 150 to 450. What that means is that these 2 brands of trail mix have the same ratio of grams to calories. Here are some examples where you cannot use equivalent fractions. You need to use what we call cross products. So in the proportion A over B equals C over D, and those letters are just there to show us, A times D and B times C are called the cross products. If the cross products of a proportion are equal, the proportion is equal, or the proportion is true. So in these 3 cases, we want to know which ones are proportions, which means which ones is this equal sign true. So I'm going to start by looking at my cross products of each one. So I'm going to start with this one, 4 times 143 and 13 times 77. So I'm going to do 143 times 7 and 77 times 13. And when I multiply those, I'm going to get 1,001 and 1,001 for both. Since both of those cross products are equal, this proportion is true. And I think it asks me to circle, so I'm just going to take my different color. That is a proportion. Let's look at this second one here. I have 12 fifteenths. Is it equal to 32 45ths? So I'm going to look at my cross products. 12 times 45 and 15 times 32. And when I look at those 2 things multiplied together, I get 10, 6, 8, 4, 544 this cross product, and 480 for this cross product. Since those cross products are not equal, this proportion is not true. So I'm going to put false down here. And I'm not going to circle that one because it's not a true proportion. This last one here, I'm going to do the same thing. I'm going to check the cross products. So 7 times 51 and 2 times 64. This is 128, and this one is 357. Those are way off. These two ratios are not equal to each other. This is not a true proportion. sometimes you have 3 pieces of information and you need the 4th, and that's the case in these. So over here, I have x over 15 equals 19 over 10. First of all, I can look at that and know that my x needs to be bigger than 15. And I know that because my numerator here is bigger than my denominator. And that needs to hold true for both of them because they are forming a proportion. They're in proportion with each other. So I'm going to look at the cross products and set up an equation from those cross products. So I have 10 times x is equal to 15 times 19. Now I have an equation that I need to solve. So I'm going to start with 15 times 19, and I'll do that on scratch paper over here. So I have 10x equals 285. And when I look at that, now I have a one-step equation. I need to divide by 10. And I get x equals 28.5. Now, is 28.5 above 15? Yes. So that answer makes sense. This is my answer to this problem. Over here, I'm going to do the same thing. So I have the cross product of 6 times 30, the cross product of 8 plus x times 20. So 20 times 8 plus x. Please notice that I'm using parentheses here because the 20 is multiplied by this entire thing. So I need to group it together. Okay, I'm going to now simplify this side first. So I have over here 20 times 8 plus x. Over here I have 180. I need to distribute. 20 times 8 is 160 plus 20x, equals 180. I'm going to subtract 160. 20x equals 20. Divide by 20. And get x equals 1. So my x equals 1 here, which means my proportion is 9 over 30 equals 6 over 20. So sometimes we use proportions when we're talking about similar figures. So similar figures are when corresponding sides are proportional or in proportion to one another. So I have these 2 rectangles here and I want to know if those 2 figures are symmetrical or are similar. So I'm going to look at the corresponding sides. This side here corresponds to this side here. So I'm going to set up a proportion of those 2 first. 6 to 15. I'm also going to look at this side as it corresponds to this side and set up another proportion or another ratio, 14 to 35, and I want to know if those 2 are equal. So I'm going to use my cross products here. 14 times 15, 6 times 35. 6 times 35 is 210. 14 times 15 is 210. So these two are in proportion with each other. So this is, yes, these 2 shapes are similar. Okay, this second example here, we're using similar triangles to find the height of this tree here. So I'm going to set up a proportion with corresponding sides. This here is the base of one triangle, and this is the base of my bigger triangle. So those 2 I'm going to set up first, 3 to 30. Then I'm going to look at the heights, and I have this height here corresponding to this height here, and this height is our unknown. So this is our x. So I'm going to do another one of 2 to x, and I'm going to set those equal because in this case we're solving for an unknown, which means we know they're already equal. And I'm going to use my cross products to solve this. So 2 times 30, 3 times examples. Both of these have multi-steps. So the first one says, in the summer, Joe mows lawns to earn money. He can mow an average of 6 lawns in 8 hours. He gets paid $20 for each lawn that he mows. How many hours will it take him to earn? $840. So I'm working with lawns, hours, and money. So I have a few things I'm working with here. The one known thing, or known ratio that I have, is $20 for each lawn. So I'm going to start with that. I'm going to say $20 to do one lawn. $20 to do one lawn. Then I want to say he needs to have $840. How many lawns will it take for him to get those $840? So I'm going to use my cross products here. And I have 20x equals 1 times 840, which is just 840, divided by 20. And I get x equals 420. Oh, I'm sorry, just 42. 42. Now I know that he needs to mow 42 lawns. And he can do this 6 lawns in 8 hours. So I'm going to do this now. I'm going to say 6 lawns in 8 hours. He's mowing 42 lawns. Where did that come from? It came from right here. In how many hours? Because that's what I'm trying to find. That was my true unknown. That's what I really wanted to know. So I'm going to use my cross products again. And I'm going to get 6x equals 8 times 42, which means 6x equals 8 times 42 is 16, 8 times 4 is 32, 336. Then I'm going to divide by 6 and get x equals, 6 goes into 3 5 times, then 6 times. So my answer is 56 is how many hours it will take him? No. Oh yes, 56 hours is how long it will take him to mow 42 lawns. Does that make sense? Which is kind of what I was just asking in my head. If it takes him 8 hours to do 6 lawns, 56 hours to do 42 lawns makes sense. Last one we're going to do here, and I'm just going to erase this bottom part so that I can see the question. Hank's new sports car has a top speed of 210 miles per hour. If he drove at top speed for 6 hours, how far would he travel? So I'm looking at miles per hour, and I have one ratio here, 210 miles per 1 hour. And he is driving for 6 hours, and I want to know how many miles he would go. So I'm going to use my cross products once again. And I have 1 times x, or 1x, equals 210 times 6. I'm going to multiply these, and I'll get x equals, because 1x is the same as x equals, let's see, 0, 6, 1,260 miles he will travel in 6 hours.